Thank you for purchasing an SFT-150 Supercritical Fluid Extraction System from Supercritical Fluid Technologies. In this video, we are going to discuss and demonstrate the installation, basic operation, and routine maintenance aspects of the SFT-150 SFE. This video is intended to supplement, not replace the user manual. Please be sure to read the manual. Section 2 is particularly important. It covers key aspects relating to the safe operation of this equipment. If you purchase the optional installation and training from Supercritical Fluid Technologies, your service person will handle the installation for you. However, you are still responsible for ensuring that all pre-installation requirements are met prior to the installation date. The following documentation is provided. Pre-installation requirements, which are sent prior to the delivery of the SFT-150, parts and accessories, which are supplied with the SFT-150, recommended spare parts, QC checklist, startup checklists, and an optional startup experiment. Pre-installation requirements. These items need to be ready in advance of the installation of the equipment. Select a sturdy bench or table. The system will need to be bolted to this table. Ensure there is sufficient space around and above the equipment. The footprint of the equipment is 61 centimeters by 61 centimeters. Electrical requirements for the SFT-150 are 220 volts AC, single-phase service. The chiller and co-solvent pump will require either 110 volt 60 Hz or 220 volt 50 Hz service. It is important to properly vent the rupture disc outlet. Use a metal pipe with a 3/8 inch NPT fitting and 1 inch ID flex tube secured with a hose clamp. The gas requirements are a bone-dry CO2 tank with a dip tube. For most applications, a food-grade CO2 is adequate. Compressed air requirements are 15 standard cubic feet per minute, regulated to 100 psi. Finally, solvents as required for your applications should be available. Setup of the equipment. The SFT-150 is placed on a sturdy bench and bolted in place. Make the electrical connections to the SFT-150. The CO2 tank must be secured to the bench with an appropriate clamp. Connect the CO2 line to the CO2 tank as shown here. The other end is connected to the CO2 inlet on the back of the SFT-150. Connect the CO2 outlet on the pump drawer to the CO2 inlet in the oven cabinet using the length of 1/8 inch tubing provided. Connect the compressed air lines, pressing the tube firmly into place as demonstrated. Connect the chiller lines. Be certain to connect the chiller outlet to the SFT-150 inlet and the SFT-150 outlet to the chiller inlet. Add coolant, 50% distilled water, 50% ethylene glycol. The co-solvent pump, if purchased, is attached to the back of the SFT-150. Connect the solvent feed line. The pump must be primed prior to use. Now the vessel assembly is installed into the SFT-150 cabinet. Insert and tighten the 4 Allen screws. Now make the connections to the RTD, heater power, CO2 inlet, and CO2 outlet. Ventilation for the rupture disc outlet, located on the top of the SFT-150, must be provided. The extract may be collected in an EPA-style SEPTA vial or container of your choice. If a SEPTA vial is used, it must be vented. If the optional flow meter has been purchased, connect the outlet from the SEPTA vial to the flow meter as shown here. Open the CO2 tank and the CO2 inlet valve, allowing the system to equilibrate to tank pressure. Use Snoop or another leak detector to ensure all connections are tight. Startup and operation. The following steps should be followed to ensure successful startup of the SFT-150. Make sure that all power switches on the SFT-150, chiller, and optional co-solvent pump are turned off. Additionally, the pump air supply and the CO2 supply valves must be in the off positions. Turn on the chiller and ensure that the chiller is set between -5 and 0 degrees Celsius. Wait at least 30 minutes before proceeding to the next step. After 30 minutes, turn on the main power switch to the SFT-150 located near the restrictor assembly. Within a few seconds, the controller's LED panel near the restrictor assembly will display the system's current parameters. These will indicate ambient conditions. Load your sample into the high-pressure vessel as shown. Sample bags are optional but highly recommended. Seal the pressure vessel as shown. Reconnect the CO2 inlet and outlet. Be sure that the static dynamic valve is closed and the restrictor valve is set to low flow. Apply pressure to the system by turning the CO2 valve and then the air supply valve. You should not hear any gases escaping. If you do, go back and leak check the gas connections. Adjust the air regulator knob, turning it clockwise to increase the pressure to the desired set point. Set the temperature for the experiment. Locate the LED labeled temperature. Press the set button, then the up or down arrow to adjust temperature, then press the set button again. Place a collection jar with a vent tube in the collection assembly area and connect the outlet to the flow meter or vent. Once the system has equilibrated at the selected pressure and temperature for several minutes, gently open the static dynamic valve by turning the valve handle counterclockwise. Slowly open the restrictor valve to achieve the desired flow rate of carbon dioxide through your sample. A counterclockwise turn of the valve will increase the flow of CO2. A clockwise turn of the valve will decrease the flow. Please note that the restrictor valve is not an on-off valve. Always use the static dynamic valve as the on-off valve. The restrictor valve is a sensitive micrometering valve, and small changes in the open-close position cause variance in the metered flow through the valve. Adjust the restrictor valve slowly to best meter the outflow of liquids from the SFE unit into the collection assembly. Never try to close it down tightly. To achieve a complete extraction, carry out several dynamic flow and soak steps. At the completion of your extraction, set the pressure to 0 psi by turning the air regulator counterclockwise and turning off the air supply. Set the temperature to a few degrees below ambient. Turn off the CO2 supply and the chiller. Open the static dynamic and the restrictor valves, allowing the vessel to vent completely to 0 psi before removing your sample. When the pressure reaches 0, turn off the SFT-150 and close the valve on the CO2 tank. Maintenance. Routine maintenance items are discussed in detail in Section 7 of the user manual. Unless otherwise directed by SFT, do not attempt to do any maintenance beyond what is discussed in the user manual. General maintenance items. Check the air filter every 6 months. Flush away any water or oil that has accumulated. Replace if dirty. Upon startup and monthly, check for leaks around the fittings of the inlet-outlet of the vessel, valves, and other connections. We suggest using Snoop or equivalent. Replace the CO2 tank when you can no longer achieve pressure. The pressure calibration should be checked yearly. A Heist gauge is recommended for this purpose. Sample vessel seals should be inspected regularly for nicks and cuts. If any damage is found, the seal should be replaced. The rupture disc will weaken over time from operation of the unit caused by flexing of the pressure load on the disc. This item should be replaced on a yearly basis. Please refer to the user manual for a more detailed explanation on the installation, operation, and maintenance of your equipment. If you require further assistance, please contact us at 1-302-738-3420 or tech support@supercriticalfluids.com. We hope you will achieve many years of trouble-free operation from your new SFT-150. Thank you.